Hello there. Today we will see the demonstration of mixing of zinc phosphate cement to be used as a base. But before we start that, we will learn a little bit about the background of a dental cement. Normally, the term cement means a substance made of powdered lime and clay which when mixed with water hardens to a solid mass after setting. It is used as a traditional building material by masons and bricklayers. The term cement also includes substances like glue which join two solid surfaces together. Now, dental cements set to a hard mass, but most of them are not true adhesives. In dentistry, their main use is mostly as lining or base materials in a cavity preparation. It also is used to lute the extracoronal or intracoronal indirect restorations. Dental cements as a whole exhibit wide range of properties, though any single cement does not possess all of them. That is why the choice of cement is most critical. Most important of the properties are adhesion to tooth structure, thermal and chemical insulation, anti-cariogenic properties, biocompatibility, and sealing capability. Coming to zinc phosphate cement, Dr. Pierce of Pennsylvania, USA is credited with first public demonstration of zinc phosphate cement in the year 1879 in a meeting by mixing oxide of zinc with glacial phosphoric acid. It is used as an insulating base under permanent filling to prevent thermal or chemical irritation to the pulp. It is also used as a cementing medium for cementing metallic, acrylic or porcelain restorations on prepared natural teeth. The cement is available in powder and liquid form. In the recent formulations of zinc phosphate cement, bismuth trioxide, calcium oxide and barium oxide are not used. Alumina is sometimes added in the form of silicon dioxide in very small quantities. The powder is manufactured by heating the thoroughly mixed ingredients at a temperature of 1350 degrees Celsius for 4 to 8 hours or longer. The fused mass is finely ground and reheated to 800 to 1000 degrees Celsius and sieved for the desired particle size. The cement liquid is an aqueous solution of phosphoric acid. The concentration is in the range of 45 to 60%. Aluminium and sometimes zinc salts are used as buffer to partially neutralize the acidity. When mixed with powder, the phosphoric acid in the liquid dissolves the surface of the powder particles and a primary zinc phosphate is formed. The supersaturated solution of primary zinc phosphate in phosphoric acid on further reaction results in precipitation or tertiary zinc phosphate in crystalline form, which is stable and relatively insoluble. However, all the powder particles incorporated in the mix are not completely used up in the chemical reaction. The outer surface of the particle is reacted upon by the acid in the beginning, and as the crystalline tertiary phosphate forms around the unreacted zinc oxide particle core, further penetration of the acid into inner mass of the particles becomes difficult. The set cement is a formation of undissolved powder core of zinc oxide inside a tertiary zinc phosphate matrix. The strength of the cement is derived from the interlocking crystals of tertiary zinc phosphate matrix. The setting cement is very sensitive to moisture contamination. Normally, the recommended procedure is to use a large, thick glass slab and slowly incorporate the powder into the liquid, spread over a large surface area while mixing, to allow for dissipation of exothermic heat of reaction. For best results, temperature of the glass slab should be maintained at 18 degrees Celsius to 21 degrees Celsius. This is known as the chilled slab technique. A frozen slab technique, less than 5 degrees Celsius, have also been recommended, whereby 40 to 50% more powder can be incorporated in a given liquid. The working time increases by 2 to 3 times and results in 20 to 40% reduction in the demonstration of placement of the zinc phosphate cement base. So this is the powder which is fluffed just before use. Let the powder settle. The liquid is turned horizontally and kept. Usually the manufacturer gives a measure, say 1.4 to 1.8 grams, which is really very difficult to maintain. For all practical purposes, one could use the spoon which is usually given with a GIC cement base and powder. So 1.5 scoops, which is level scoop, can be taken. Immediately recap the powder for the liquid, turn and drop the liquid to full drops, totally inverted, a little distance away from the powder. Now we start the mixing by dividing the powder into small increments, keeping the excess aside for proper consistency. Now we will start with the smaller increments, mixing them over a wide area to dissipate whatever heat is generated. And of course we have learnt about the chilled glass and frozen glass technique. So this is circular motion, figure of 8 or folding method. We are mixing it Each increment may be mixed for around 15 to 20 seconds before the next increment is added. So this mix is a proper mix for placement as a base, and we will not be needing this excess powder. Now our tooth preparation is ready here. We will take the cement, usually 0.75 or 0.5 millimeter is required. We will allow a little bit of cement to be placed, and we have already checked the convenience form. We have selected our cement carrier and cement condenser, and we will just place the cement. Do not forget the eggshell wall, both the pulpal and the eggshell wall. For the eggshell wall, you could use this kind of a plastic filling instrument, or under working consistency we will get at least 1.5 to 2 minutes of solid working time here. We can remove any excess with the help of a chip blower. I am using alcohol, which can be either 70% or 90%, which acts as a separating agent without disturbing the mechanical properties or altering the chemical properties of this particular cement. Now always remember, after we have placed it, we have to smoothen it with our instruments, which is hand instrument only. Many students and clinicians tend to use rotary instruments to smoothen the zinc phosphate base, which is a very wrong procedure because it might lead to microfractures and the strength and the integrity of the cement base is lost. So this is now the finished tooth preparation with the base. At this stage, we will slightly try and tweak to release the zinc phosphate cement from the undercuts so that the silver amalgam can get inside, totally getting locked within the cavity preparation. In similar manner, we will see how a class 1 preparation can be done. So the powder is fluffed and a level measure scoop of the powder is dispensed. Immediately recap, otherwise we invite moisture contamination. Now for the liquid, first we hold it horizontally and then we invert, expressing 1 drop. The powder should be divided into few increments. And we start with a small increment spread over a large area, because as we have discussed, the reaction is exothermic. We have ensured that the glass slab is thick, it is dry and it is cool, but not below the dew point. If it is below the dew point, that invites the moisture incursion, which will reduce the strength of the cement and the other mechanical properties. Now we have incorporated the entire powder into the liquid and we will look at the consistency that we have achieved. Now we will keep the cement aside and we will prepare the tooth to receive the cement base. For that purpose, I have now taken alcohol here. This helps to separate the zinc phosphate cement. Now look at the consistency of the cement. We can use a cement carrier which might be of this design. We are spreading the cement evenly on the pulpal floor, and for this purpose, since we do not want our cement to stick to our instrument, I have used 70% alcohol for this purpose. Now the cement base has been evenly applied. As we can see, it is smooth. We free the internal line angles of the undercuts, and to remove all this excess, we will use a chip blower. Now can be removed with the help of a chip blower. We will check the finish of our cement base before we move on to placement of our restorative material. So many a times it so happens that clinicians and students, they tend to use a rotary instrument to smoothen the base. It is a very wrong approach because the base has not achieved its final strength, and this leads to microfracture. So our attempt should be to mix our cement to a smooth, creamy consistency which is thick but not granular, that we can place and also shape into the desired form on the pulpal floor as a smooth surface. And we can use our cement condenser dipped in spirit or alcohol 70% or 90% to just smoothen it so that it does not stick to our instrument. Thank you very much for watching this.